Again, we're in Chapter 5, Section 3 this time, number 11. The amount of a random variable x of a beverage in a can labeled 12 ounces is normally distributed with a mean of 12.1 ounces and a standard deviation of 0.05 ounce. The can is selected at random. A. Find the probability that the can contains at least 12 ounces. B. Find the probability that the can contains between 11.9 and 12.1 ounces. Alright, so we have a random variable x. We have our mean equaling 12.1 ounces and our standard deviation equaling 0.05 ounces. So in A, we're looking at the probability that x is greater than equal to 12 ounces. This will be the same as the probability that x is, no, I can't do it quite like that. I'll have to grab my eraser, and I can't use an eraser on the screen right here, so I come back and erase that way. Now I can drop back here. So that's the same as 1, what I was trying to say was 1 minus the probability that x is less than 12 ounces. Okay, well, we don't have a table for this. We're in this whole section of how we get from the general distribution to the standard normal distribution, where we can actually look things up in a table. So in this case, we'll do 1 minus the probability that z is less than, and we have to transform this. We have our value of x, 12, subtract off the mean, 12.1, and divide that by the standard deviation, 0.05, because that was the x minus mean over sigma gets us our z. Alright, so now we have to calculate, do some math here, right? Z, get that there, is going to be, let's see if I calculate that out, that is going to be minus 2.0. So this will be 1 minus, again, I don't have to have the p there, so I have to erase it. The challenge of jumping back and forth with digital ones here. Okay, so z less than minus 2.00, I looked that up in the table. So row minus 2.0, column 0.00, this is going to be, let's see, 0.0228. I'm going to subtract that, I get 9772. Alright, so the probability that the can contains at least 12 ounces is 97.7%, essentially. Okay, B. Find the probability that is between 11.9 ounces and 12.1 ounces. Okay, this is going to be the same as a transformed version of this, because I have to transform from the general distribution back to the standard normal distribution. And I do that again by taking the value of x, which here says 11.9. I'm going to subtract off the mean again, which is 12.1, and then divide that by the standard deviation. It's going to be less than z, and 12.1 minus 12.1 over 0.05, and this is going to be the same as, so the probability that z is less than, I'm just going to write this out since I have it there, 12.1 minus 12.1. I'm starting to do that in my head and said, let me just wait a minute, minus the probability that z is less than this other value. Alright, so it's the probability that z is less than 0 minus the probability that z is less than, let's see, 0.2 divided by 0.05. This will be minus 4.00. This will be 0.5. Don't even have to look that one up because half the probability is going to be less than 0 and the other half is greater than 0. Alright, so I need to look up minus 4.0, and that's way off the chart. So it's less than 4 significant digits, so it's way out there, so it's essentially 0. So you wind up with our answer being essentially half. So half the cans will be between that. So the other cans will be slightly more, slightly less. Alright.